In this video, I'll be teaching you guys how to fill out Venn diagrams for the difference, the symmetric difference, and the complement set operations. Now, if you haven't watched my previous video, if you don't know the basics of filling out Venn diagrams, go ahead and watch that previous video first. I talked about unions, intersections, and complements as well, but of course, I'll do a brief overview on them every single time I go through one of those in this video. So, let's go ahead and begin with the difference, okay? So, to fill out Venn diagrams with the difference operator, let's look at the set on the left side. We know that this circle represents A, right? I have it labeled A. So this entire circle represents A. So A is on the left side of the difference, so we should fill out A first. Okay, so we fill out this A circle, and now let's look at B. Well, remember, if you know how to use difference operator for like sets of numbers, let's say, not with Venn diagrams, you know that whatever's in B, you should remove from A. Okay? So whatever's in this section, in this part of B, you should just completely wipe it off the map. And what's in the circle of B? It's this guy right here. This little part where A and B share the intersection between their Venn diagrams. So what do? Well, we should remove this section, right? We should erase this section. So let's go ahead and refill out A, like so, to get A minus B. So what do? We filled out A entirely, right? Like this. And we realized, this portion right here is also a part of B. So all we did was wipe it off the map. And we left the rest. We left the rest right here that's part of A. Okay? So that's how you do difference. This is what A minus B looks like on Venn diagrams. Alright. How about A symmetric difference with B? Well, for this, you can fill out A, right? And you can also fill out B. Let's fill out both A and B. Okay, let's not overlap the B. Let's make this look nice. So once we fill out A and B, what does the symmetric difference do? Well, the symmetric difference, sort of how you hear difference, now you know you should remove some color, okay? You hear the difference, you should remove some color, right? Symmetric difference has the word difference in it. Again, you're just removing something. So, what part are you removing? Well, you're removing this part where they share an intersection. Only where the coloring shares an intersection is what you erase. So if I were to make this look nicer, if I were to fill everything out, right, this would be A symmetric difference with B, or exclusive OR for you computer engineers. All right, what about B minus A? Okay, I just want to show you the opposite of this, right? I want to show you what B minus A looks like and what A minus B looks like. Let's go ahead and fill out B first, right? Whatever set's on the left side of this difference operator, you fill out that circle first. So let's fill out B like this. Like this. And fill out this section as well, right? So remember, we fill out B, and whatever section is part of A, we just remove it from the coloring. So we know that this entire section is a part of A. But look what we have. We have some color here. We know that this section is part of A. So what do? We erase it, okay? But we leave the rest of what we colored before the same. And there it is. This right here is B minus A. Notice how A minus B and B minus A are different. If you want a refresher, this is what B minus A looks like, and this is what A minus B looks like. So when you're doing the difference operator, it matters. The order in which you put the sets matter, okay? And the main thing about this is filling out the set on the left of the difference operator first, okay? Fill this out and remove based on B, okay? So fill out the left side, color the left set, and remove everything from the right set out of your coloring. All right, and I'm just going to do a little review on the complement here. So what is the complement? Well, the complement is just a line. It's a bar at the top. And it's basically everything that's not A. So what's everything that's not A? Well, it's even outside of the Venn diagram. Everything is not A. And oftentimes, outside the Venn diagram is defined as set U. Okay, it's just everything that's it's literally just everything. Set U is just everything. But for drawing's sake, I'm just not going to leave the U there. And for not B, right? Or complement B, it's everything that's not B. So we fill out everything outside the circle B, you know, trace around the circle B. And this right here is complement B. Okay? That's a little refresher on the complement. Now we can move on to more problems. So for this problem, I first want to explain the order of operations. Of course, you complete the complement set operation first, but this is, of course, before parentheses. Parentheses are always have the highest order of precedent. So I didn't really feel the need to mention that because, well, in PEMDAS, P stands for parentheses. Hopefully you know what PEMDAS is at your grown age. But we have intersection next. So the intersection is completed after you complete complements. The union difference, I put these on the same line because typically they're treated with the same order of precedent. So if we had A union B minus C, we would just perform this operation left to right, right? Since we have a union and difference, we don't really have intersection or complement. We could just perform this left to right. But if we have parentheses, of course, follow the parentheses. Now, an important thing to note is that if you do the union of A and B first, and then you subtract C or take the difference with C, this will give you a different answer from B minus C union A. So remember, if you don't see parentheses, just follow left to right, okay? Just do this left to right if you have union and differences. Oops. And for the last one, it's symmetric difference. This XOR symmetric difference is last. How sad. But now that we got that out the way, let's go ahead and solve these. So we have a difference here. We have these parentheses. So of course we perform the parentheses operations first. Oops, I just erased the wrong thing. So we have A minus B. So remember with the difference, we fill in A first. So let's fill in A here. And we take the difference with B. So what's inside of B? This ring, this entire ring is B. And you see the shaded region here is already shaded in, but we want to remove it because we want to subtract whatever's inside of B. So we remove this region right here. All right, now that we have this, we take the union with C. So what does a union do? Well, a union just combines this entire section of C with A. So all we need to do is fill out C. That's all. So we should just fill out C, right, to take the union, and there we have it. This right here is A minus B, parentheses, union C. For this next problem, we only have symmetric differences, so it doesn't really matter what order we do it. We'll get the same answer at the very end because these are commutative, right, or commutative, depending on how you pronounce it. So first things first, let's go ahead and fill out A, and let's go ahead and fill out B. So fill out A like so, and fill out B like so. Now remember, for the symmetric difference, we only remove the shaded parts that overlap. So what overlaps here? Overlaps is this part, this portion right here. So let's go ahead and fill everything but this portion. So we have this. Do not fill out the little centerpiece like so. All right, next, now that we have solved A with the symmetric difference of B, now we need to take the symmetric difference with C. So remember, again, we just fill this out. So let's go ahead and fill this out. Let's go ahead and choose orange. Fill out C. And any parts that overlap, we erase. Which parts overlap? This portion and this portion right here. So all we need to do is remove these two sections. So if we color everything in again, we should get left off with this. So this right here is A, symmetric difference B, with the symmetric difference of C. So for this next problem, let's look at the operations. We have a difference here, and we also have an intersection here. Which one's more important? Which one has a higher precedent? It's the intersection. So we want to calculate this section of our problem first. All right, how about this? We see a complement here. We see an intersection. Which goes first? The complement, right? The complement's more important. So let's go ahead and calculate the complement first. What's the complement, or draw out the complement of A? Complement of A is just everything but the circle A. So let's fill everything around the circle or the Venn diagram portion of A. Booyah. This is what it is. And now, we want to find its intersection with C. So we want to fill out C. And how do you find the intersection? Well, the intersection is just the part of what we colored that overlapped. What part overlaps? This portion overlaps, right? You see the orange and the blue overlap in this portion, yellow portion that I circled out. Well, this looks like a bean more like. This looks like a bean. So let's say that I beaned out. And let's fill out that section, right? So this right here is the complement of A intersection with C. All right, now we want to take the difference with B. Well, remember, the difference of B, we don't have to fill anything out. We just need to erase things. So what's the difference of B? Well, this right here is B. We just want to remove anything that's inside this ring, right? Erase any coloring that's inside this ring. What coloring is inside this ring? It's this. It's this right here. So let's remove this section right here and then recolor in what we have. And this is the result. Last problem. But for those of you that are watching right now, or maybe exactly 1 year, 2 years, 3 years, any amount of years, any exact amount of years from now, hope you're having a great Thanksgiving break. I am currently enjoying it. Not gonna lie, today I was supposed to have classes, but I just used all my drops because I wanted to start my break earlier. So I hope you guys enjoy it. There's I don't know, am I gonna have turkey? Might not have turkey. I don't know what my parents are gonna cook up. I'm probably just gonna meet up with my Chinese fam. And for those of you who don't know, I am Asian. I am Chinese. Yes, I like reading and I like math. Okay, and that's not even a stereotype. I'm literally making math videos. But I encourage all of you guys to be thankful at least for one thing. Truly, it is. I'm an educational content creator. Maybe I shouldn't be giving you guys this advice, but really. I'm serious. If you list out the things that you are grateful for, you're more likely to be happy in life. And I heard this quote recently on TikTok. It was like worrying today does not take away tomorrow's problems. It only takes away today's peace. All right. So keep that in your head. Just be grateful for every single moment that you have. And if it's Thanksgiving for you, write down a list of things you're thankful for. Seriously, man. But maybe I should get back into the problem. Okay. Yes, get back to the problem. You stupid educational content creator. You want to be organic chemistry tutor. I'm not a wannabe. I keep seeing comments like that. I keep seeing comments like, this is the premium version of organic chemistry tutor. I'm not trying to be him, bro. I'm not trying to be him. He's my op. He's my number one op. My one-sided rivalry. But anyways, let's go ahead and start this problem. Looky what we have here. We have operations, okay? We have the symmetric difference and we have the intersection. Which one has higher precedent? It's the intersection. So we should calculate this first, okay? So we should calculate the intersection of A and B first. What's the intersection of A and B? Well, hopefully by now you guys know. I'll just shade it in. I won't do all the incremental steps. I don't want to waste your time. And now we have that. We should actually take the complement of C. So let's go ahead and take the complement of C. Let's just color in everything that's not C. Let's color everything that is not C. So everything that's not C is this, okay? And remember, what the symmetric difference does is removes any overlap. So if any of the colors overlap, you should erase that section. And which section overlaps? This one right here, right? We have the blue and the orange overlapping here. So we should remove this yellow section right here. So with that, we should remove that yellow section. It was this one, so let's color in this. And we should just leave in the rest. Right? Let's leave in the rest. And now, this is the answer to the first problem. So check mark. Let's put a special check mark. Let's say thanks for the Thanksgiving spirit. Thanks. What am I saying thanks to? I'm saying thanks to nothing. Okay, maybe I should have erased the problem first before I did that because I usually click undo. So thanks. Let's say thanks. Just to say thanks. Why not? Why not say thanks? It's manners. I think I hit my mic there. If that hurt your ears, holy shit. Apologies, big apologies. All right, now that we have this, let's look at the next problem. With A minus B union C, which one has the higher precedent? None of them, okay? So if you see a difference or a union together, well, you should just do the operation from left to right. So let's do this from left to right. Let's solve A minus B first. So A minus B. So remember, we color in the set on the left side, right, of the difference. So what's on the left side of this difference? It's A. So now that we have that, let's draw a circle around B and just erase every single coloring we have within this circle of B. And what's that? Well, it's this section right here, so we should just erase this section. So let's color in everything but that section. All right, now that we have that, we should just take the union with C. So let's go ahead and take this union with C. Let's just color in C with blue, like so. And this right here is A minus B union C. All right, I just noticed this. I did this problem already. So let's tack on something new. Let's tack on symmetric difference with B. All right, symmetric difference with B. Man, I already wrote this problem, bro. What am I doing, bro? I wrote this in the last problem. Maybe you guys noticed. Hopefully you guys noticed. If you didn't, that means you weren't paying attention. I don't know why I started buzzing there. But anyways, remember, symmetric difference. We just color in everything in B. And whatever overlaps, we erase it. So what overlaps? This section right here. So we just erase this and leave all the color behind. Okay? So that's going to be a little tedious process, but I'll fill out everything for you. I'll fill out everything for you. Oops. Okay. You know what? Oops. I'll fill out everything for you right here. Like this. And let's put this back, because when I click undo, it erases what I write. So this right here is the answer to this. Now, when I click undo to remove this again, it's just going to erase this again, but ignore it. Okay, ignore that. Let's solve this problem. Let's take the complement of C. So the complement of C is just everything but C. Right? So we took the complement first because the complement has the highest order of precedent besides parentheses. And now what do we do next? Do we take the intersection or the union? Which one has the higher precedent? Let's put a check mark around this. Actually, that check mark is just going to erase when I undo. Which one has the highest precedent? Intersection or union? It's the intersection, right? So let's take the intersection of C complement with C, right? Let's color in C. Now here's the thing. Is there any intersection? There's not. There is no intersection here. So what do? We color in nothing. And this right here is actually a set identity. Okay? This is one of the set identities. I'm going to cover that next video. That's my next video topic. But remember, if you take the complement of something and try to find its intersection with itself, you're going to get nothing. And the reason why is because of this, right? I just showed you the Venn diagram example of this. What do I mean by that? So we have nothing so far. So this part right here is just nothing. Right? It's just nothing. Because there is no intersection here. Now we just take its union with A. Remember, with unions, all we do is just color in A. It's very simple. Unions are very simple. So basically, this guy right here is equivalent to just A, right? We just filled in A, that's all. And let's put check marks around there. Let's add a thanks here for the Thanksgiving spirit. Thanksgiving spirit. Thanks, thanks, thanks. All right. Well, Christmas. Oh, can't wait till Christmas comes. When will Mariah Carey break out of her ice encapture? I don't even know what it's called, right? She just screams, "It's like that every single year before Christmas, and that's how you know the Christmas spirit started, and that's how you know you should put up the trees. But I feel like after COVID, like people don't put up trees anymore. I don't know. When I was a kid, I sound like Unc right now. I was born in 2005. Okay, so I'm 19 right now. So when I was a kid, Christmas felt so different than it does now, man. I think it's just because we grew up, but I hope kids nowadays are enjoying their Christmas. If you have any questions, put it in the comment section. If you found this video helpful, consider subscribing and liking the video. Thanks for watching.